Section 8.3 Part 1 is what we're doing for this. 8.3 is going to be split up into 3 parts. Yes, I'm splitting it up into 3 parts. Hopefully this will make things a little bit easier. The first 2 parts we're going to be reviewing some laws for logs, which is not review, so it's not technically a review. This is just 2 lessons on how to do some laws with logs. Let's get into this. Reminder that you should be coming, if you're watching this, hopefully the last section was 8.1. You should have skipped 8.2, hopefully. We'll see. Okay, what are the purposes? So we are going to discover the laws regarding logarithms and to solve some problems using the product law and to solve some using the quotient law. You might notice with this, product and quotient laws. This should sound familiar. Let's look at the product law. Recall for exponents, this is your expression. So if you have a base to the power of x times the same base to the power of y, you add the powers. This should be familiar, hopefully. For logs, we're going to do something similar to this. So log base c of xy equals log base c of x plus log base c of y. This is a rule that you'll need to know. So I'm not going to give you this on the formula sheet, just like I didn't give you this exponent law, but you need to know this. This is going to be important. So let's try this out. Simplify log 5 plus log 6. If I say simplify, that normally means combine them into a single function. Here's our expression. Because I'm adding the logs, I'm going to times inside of the log. Make sure you recognize adding separate logs combines into multiplying inside a log. I see many students who try and do the reverse of this. Please don't. It doesn't work. I can multiply what's inside of the log. This is our answer. You just say it like this. If I say to simplify, just put it into one log. How about this one? How is log 600 related to log 6? In a question like this, when I'm talking about relationship between them, I need to take log 600 and get it so that I have log 6 by itself. So let's try to combine this or get to log 6. I notice that I can separate out log 6 times 100. So because I can put that product in there, I can separate them as such. Now you'll notice I have log 6 by itself. I can simplify the last term into 2. This is how they're related. Log 600 is equal to log 6 plus 2. So it's related by this plus 2. Another example. Express log 24 as a sum of logs. For this, all I need to do is, you notice I keep pausing because I'm about to say so, and then I pause to think if there's another word to use, and then I just don't use a word. It's going to happen a lot. At least I'm not saying so as much. I can take this and separate it into log 4 plus log 6, because I've expanded those out. I can even expand those out, where log 4 is equal to log 2 plus log 2, log 6 is equal to log 2 plus log 3, I could have even done the original as log 3 plus log 4. If I want you to do a sum of logs, if I don't give you something specific, it's kind of a generic equation. But normally when I ask you to express it as a sum of logs, there'll be variables. So then it'll be in reference to log x and log y, which you'll see coming up. Again, simplify, meaning combine them together. Here's our expression. Put them all in one by timesing them together. You get log 40. Hopefully this is pretty straightforward. Again, this takes a little bit of practice to understand you're adding separate logs and then multiplying inside of a log. Let's look at the quotient law. Recall for exponents, if you're dividing exponents with the same base, you subtract the powers. So for logs, if I have a log where I'm dividing 2 things, I'm subtracting logs. So again, exponents, if you're multiplying, you add the powers. If you're dividing, you subtract. For logs, if you're multiplying in the log, you add separate logs. If you're dividing in logs, you subtract. Let's try it out. Expand log base 7 of x divided by y. So I've got a division inside of the log. So I simply write it out as subtraction. And notice the base of the log stays the same. That doesn't really matter. Another one. Expand this one. Again, I've got log of what's on the top minus log of what's on the bottom. So that whole entire log. And inside that log base 2 of y, z, those two things are being multiplied. So I can expand that one out just using the product law. The purpose of this should be quotient law. Whoops. To solve problems using the quotient law. And then I can bring the negative into the terms in there, and then this is going to be my expanded equation. Notice again, I'm expanding it to talk about each individual log with each variable. Let's simplify this one. So I'm going to put the terms that are positive. The positive logs stay in the numerator. The negative log goes in the denominator. And then simplify inside that bracket. And notice here, log base 5 of 25, I can simplify this into an actual whole number. So 5 to the power of what gives you 25? That's just 2. So that's as simplified as you get. If it's not a perfect log, do not turn it into a decimal. Keep it as a log. Yeah, that's why I said that. Since 5 to the power of 2 is 25, this is your answer. Now we're going to write this log in terms of separate log x and log y. This is what I was alluding to before. Because there's a product inside of the log, I expand this out. You can look at it like this. Write these out as separate logs. First thing, log of 100. That gives me a whole number. That's just 2. And I've got 2 log y, so I can combine those and get this is my final answer. I don't care about ordering with this. If you keep it like this, that's fine. If y equals 10x, how would log 10 and log y be related? So in order to do this, let's take the log of both sides. So now I've got log y by itself, but I need to separate log x out. So I can't just do anything with the 10. I need to first expand that side. Since it's 10 times x, I can write them as separate logs with a plus, and then simplify log 10. So log y is 1 greater than log x. That's how they're related. I know this is a lot of practice problems, but I want to make sure you can see this a lot. Simplify. Again, to simplify, let's combine all these in one. Notice I can't simplify anything yet, because there's not 4 to the power of nothing gives you 32. 4 to the power of nothing gives you 8, except it's a decimal. Combine them all into one log. Simplify in the bracket. So I can write this out now as an exponent. So 4 to the power of x equals 128. Notice I can write this now as base 2. The bases are the same, so the powers must be the same. X is equal to 7 over 2. So this is a nifty trick to be able to see that you can write out the bases as the same. This is a trick that you can do to actually solve this out. Simplify this one. Okay, now we're getting into more complicated ones. I've got a log minus a log. First thing I want to do, combine those. Here's what I get. And when you look inside the brackets, you should start to recognize something. I can do some factoring. Yes, we're going to be doing factoring. You'll need to get used to that. So here is both of these expressions factored, and I can cancel out a term. I can cancel out the x minus 4. So here is my log. I cannot simplify that anymore, so we're going to leave it as so. If you remember, for logs, there's a rule. X has to be greater than 0. There's also a rule for the bases, but we have nothing with the base that we need to deal with here. So I need x to be greater than 0. So looking at my two original equations, I'm going to get a restriction that x needs to be greater than 4. Because if you look in my factored version, if I had an x value that was less than 4, I'm going to get a negative number in one of the logs, and this won't work, or a 0. So if you look at the original equation, I've got minus log base 2 of 3x minus 12. If I stuck in 4 into there, I'd have log 0. And this doesn't work. If I pick some number that's less than 4, so suppose I put in 3, 3 times 3 is 9, minus 12 is a negative number. I can't do a log of a negative, so this is going to be my restriction. So that is what you're going to do with this. You need to look at your original equation and try and figure out the restrictions for that. That is it. So that's 8.3 part 1. Those are the first two log rules. And next section I'm going to look at the last one, looking at the power one. So I'm really hoping that last video worked. If you followed the instructions that I gave you, you should have, this should change the incident. It shouldn't happen. The world would not end up in the place where it is right now. Yeah, hopefully you do that. But if somehow this video doesn't work, or people still aren't listening, I am also just going to post this. Maybe somebody will be able to duplicate what I've been able to do and convince people. So I basically couldn't figure out time travel. I tried that for years. It never worked. Never was I able to go even back a couple seconds. So I devised this way. I could send a video back through time, back somehow through the internet, go into the past internet, past websites, and just post a video up there. And I didn't have to myself travel back in time. And this was the only way that I could go past the incident. That's the main thing. So if all else fails, hopefully someone else can see this. They can remember how I managed to reach into the past, and someone else can convince people to listen and to actually do what they're asked.